In this video, we're going to look at an example of a uniform motion problem. Now, when we're talking about uniform motion, we're saying that we are moving at a constant pace, or that we aren't like speeding up or slowing down. So this is what we're talking about. And we're also going to primarily be using the equation that distance equals rate times time. Now, in order to utilize this, we like to make a chart for this level. We're going to be talking about how systems of equations can come into play in our next section here. So be aware that systems of equations are definitely a different way to do it. But what we can do is we can set up essentially a little chart. We can have a distance, a rate, and a time. Okay, and then we're going to be able to mark information down for these things in both our people's cases. So let's go ahead and read the question. And as we're reading the question, I'm going to go ahead and just put some information into our little chart. So the first part of this says that two runners start at the opposite ends of a 15-mile long trail. The two meet when person A has been running for 1.5 hours. Okay, so I'm going to just start by saying person A has been running 1.5 hours. Person B has been running for 0.75 hours. Person A is 2 miles per hour slower than person B. So this is where I have to be a little bit careful, right? So what I'm going to do here is I'm going to say, okay, if person A is 2 miles per hour slower than person B, then person B, I'm going to say that their speed or their rate is R, and the rate for person A is R minus 2. Okay? Then we're going to say, okay, we also know that they do a combined distance of 15 miles. So that means that one is going a longer distance and one is going a shorter distance. Just because I said R went with B, I'm going to just say the distance that B goes is D. And then A has traveled the rest of the distance. So keep in mind, they're coming from opposite sides. So let's say person A is coming from the left and person B is coming from the right. The amounts of distance that they travel have to add up to 15. So for example, let's say one person ran 5 miles. The other one would have had to run 10. If one person ran 2, the other person would have had to run 13. So in order to figure out what goes into this other spot, we're just going to subtract however much person B ran from 15, and that'll tell us how much person A ran. Okay, so now we have our distance, rate, and time information for both of our problems, for both of our people. So we can essentially create an equation because distance equals rate times time. So in my first one here, I'm just going to go ahead and switch some colors up. In person A, I know 15 minus D is the distance. I know the rate is R minus 2. And I know the time is 1.5. For person B, I know D is equal to R times 0.75. Now, you might be looking at this and going, oh, that looks terrible. But the good news is that this actually isn't nearly as bad as it looks. What we're going to do is we're going to simplify this side of the equation, and then we're going to solve for D here, okay? That's going to make this next step much easier to work with. I'm going to go ahead and just shift this over to a fresh board. So looking at that first equation, when we distribute the 1.5 through the parentheses, it becomes 15 minus D equals 1.5R minus 3. Then I want to solve for D. So I'm going to subtract 15 from both sides. That gives me negative d, notice that there's a negative here, is equal to 1.5r minus 18. And then to finish getting d by itself, we're going to multiply through or divide through by -1, which essentially means we just change the signs all the way through. So now we know that the first equation is really d equals negative 1.5r plus 18. But we also know that the second equation is really just d equals, and if we multiply these together and just put the number in front, we have 0.75r. So because we know what d equals twice, we're really just going to combine these two into a single equation. If d is equal to 0.75r and to negative 1.5r plus 18, then I can set those two things equal to each other. Now I'm going to be able to solve for r. I'm going to add 1.5r over to this side, and that's going to give me 2.25r equals 18. And remember, this could be done in decimals or fractions, depending on what problem you're given and what the context is. So either way is fine. But no matter what you have here, you're welcome to use your calculator in order to do the next part, which is divide both sides by 2.25. When I divide both sides by 2.25, I get that r is equal to 8. So now I know the value of r. I'm just going to pop back over to the question. Person B had a rate of r. So person B ran at 8 miles per hour. But person A was 2 miles per hour slower, so they moved at 6 miles per hour. So how fast is each person running? Person A is going 6 miles per hour. Person B is going 8 miles per hour. This particular question didn't ask for you to find out how far each one went, but if you wanted to find them out, you would just substitute the value of 8 in for r in each equation, and then that would tell you the distances that were traveled. There you go. I hope that was a helpful introduction to how to use tables for uniform motion problems.